Welcome to the first edition of the Chain Coding Challenge, where each coder must continue what the other one started. Let's meet our two contestants. On the left, we have Frank. Frank is a self-taught front-end web developer. He likes to experiment with code, build web animations, particle systems, and JavaScript games. And on the right, we have Radu. Radu has a PhD in computer science. In his spare time, he makes coding parodies, gives motivational tips, and programs non-stop for 24 hours. To find out who will start this time, we spin the chain of choice. And it's Frank! Let's see what he has in store for us this time.
Hi coders! In this episode, I want us to get full understanding of fractals and how to draw them on HTML canvas. This video will be a regular vanilla JavaScript tutorial as usual, so feel free to code along with me if you want. We are just putting a spin on it. When I'm done with my fractal, I will send it to Radu to see if he can build on that and take the effect to the next level. When he sends it back to me, I will add another feature on top of his codebase and maybe send it back to him again. Are you curious what comes out of that? Because I certainly am. We call it Chain Coding Challenge. This video will be very beginner friendly. If you know basics of JavaScript, you should be able to follow, and I will do my best to help you understand. I've done a lot of particle systems lately, so why don't we do something different? Let's try fractals for a change. Let's build a fractal Christmas tree. Also, click the like please if you get any value from these tutorials. In index.html, I just link my style CSS and script.js files. I also create two HTML canvas elements, one with an ID of canvas snow background, and the other can be called, for example, canvas tree branches. I will add inline onload event to body element. This will execute JavaScript immediately after everything inside body element has been loaded. I will call that function, for example, main, with brackets like this. In script.js, I declare that function, and for now I will just console log test to see if it works. If you see test in console, you know you are good to go. In style CSS, I use canvas tag to style all canvas elements at the same time. I give them position absolute, border 1 pixel solid black, left 50%, top 50%, transform translate -50% will center both canvas elements vertically and horizontally in the middle of the page. I also take canvas snow background by targeting its ID like this, and I give it a light blue background color. In script.js, I declare global variables first. Canvas width will be 480 pixels, and canvas height will be 620. I also declare let variables called snow bg canvas and branch canvas. These need to be let variables because I will reassign them later to their associated canvas elements. To do that, I will create a custom reusable function that will take ID of that canvas as an argument, and it will set it up for me. Later I will call it like this: snow bg canvas variable from line 4 equals to my custom initialize canvas function from line 7, and I pass it ID of that canvas. On line 10 in index.html, I can see I set ID of my first canvas element to canvas snow background, so I pass it here in quotes. If you've never passed arguments around like this before, simply set what's happening here is that this ID we pass as an argument here becomes this variable. Same as if I set const canvas ID equals canvas snow background. Now inside my custom initialize canvas function on line 7, I can put some reusable code. It will be the same code we always use for canvas setup in every project, but instead of writing this code for each individual canvas element, I just write it once, and when I call my initialize canvas function and I pass a different canvas ID, it will run all these tasks for that particular canvas. It's a good practice to make your code so-called dry, D-R-Y. Do not repeat yourself if you don't have to. I can create const variable called canvas as usual, and I set it equal to document.getElementById, and I pass it canvas ID from line 7. When we call it later on line 13, this canvas ID variable will be passed as argument as canvas snow background, so it will set that canvas up. I also set size, so canvas variable from line 8 dot width is equal to canvas width, and canvas height is equal to canvas height from line 2. Then we can return canvas variable from line 8, which now holds a reference to our canvas element we have just set up. So here on line 16, I called initialize canvas and I passed it ID of my first canvas. It targeted it with getElementById on line 8. It set its width and height on lines 9 and 10. And using return keyword, it gives us that element so we can assign it to our snow bg canvas variable here on line 16. When I run the code, you can see the background canvas got resized correctly. All I have to do now is to run the same code for my branch canvas as well. Branch canvas variable from line 5 equals to my custom initialize canvas function, and I pass it ID of my second canvas element. And it gets set up again. Instead of declaring getElementById, canvas width, and canvas height for each individual canvas element, we automate it by using this utility function. This would be especially useful for projects where you use many canvas elements. Code like this saves you a lot of repetition. You might be wondering on line 8, how can I use the same constant canvas variable and set it at first to my first canvas, and then run this function again and assign it to my second canvas. We all know that constant variables cannot be reassigned to a different value. To do what I'm doing here is possible because const and let ESX variables are block scoped, which means they only exist within its closest set of curly brackets, in this case these brackets right here. That's why when I call this function again for my second canvas, this const variable will be a completely different independent variable even when they are called the same name, canvas, because they each exist in their own scopes and they don't see each other. We are creating one scope here that runs its code between lines 7 and 12, and then on line 17 we are using the same code from lines 7 to 12, but we are creating another independent scope. JavaScript scopes and closures are complex topics, so let's leave it like this for now. I will talk about it more in future tutorials. I remove console log on line 15. I create a custom function called draw branches. This function will basically just draw a single line from one point to another. It will then rotate canvas, adjust length and width of the line, and call itself again to draw another line. It will call itself over and over like this very fast until it draws a complete fractal that looks like a Christmas tree. Slight modifications can also make it look like a regular tree or a snowflake. It's all very similar technique. My drawBranch function will expect 5 arguments. Canvas will specify which of my 2 canvas elements I want to draw on. Start will be a small array with 2 elements that will represent x and y coordinates from which we start drawing the current branch. Every time we draw a branch, these coordinates will move along that branch to create the next segment. Len will be the length of the current branch. Each time it will get shorter and shorter as we go from the main trunk to the outer small branches. Angle will determine value in degrees by which we rotate the canvas after drawing each set of branches. This will determine how spread out our tree is. I will show you how exactly it works when we have something drawn on canvas. Branch width will determine how thick the lines are. We will start from a thick tree trunk and slowly make it thinner and thinner as we create smaller and smaller branches. First, I have to complete canvas setup, so I create ctx variable, shortcut for context. I take canvas variable we pass here on line 19, which I will point to my snow canvas or branch canvas from lines 15 or 16 later when I call my drawBranches function. You will see in a minute. I set getContext to 2D, which will invoke built-in Canvas 2D API object that gives us access to all drawing methods we will need today. Now I can call beginPath, which will tell JavaScript I want to start drawing a shape. We will draw just a single line. I call ctx save. This saves current canvas settings, so we can later jump back to these settings by calling ctx restore, same as you use save and load in a video game. I need to save here because I will be translating and rotating canvas around so that this one line, drawn many times, creates a tree. Let me show you what I mean. I set ctx line width to be equal to branch width variable we pass as argument on line 19. Then I call ctx translate built-in method. This method expects two arguments for x and y coordinates, and what it does, it moves draw in position 0, 0 on canvas, which normally sits in the top left corner, to these coordinates we pass to it. Let's leave 0, 0 there for now. I will go back to this shortly. I will also call canvas rotate and pass it angle from line 19. Rotate expects value in radians, and our angle will be in degrees for easier readability. To convert degrees to radians, I simply multiply angle times math.pi divided by 180. Center point of this rotation is position 0, 0, so that's why on line 24 I will be translating position 0, 0 along the tree as new branches are added, you will see. I call ctx move to, which determines starting x and y coordinates from which a line is drawn on canvas. I hardcode 0, 0 here, but these will not be static coordinates. 0, 0 would normally be top left corner of canvas, but in a minute I will translate position 0, 0 somewhere else using translate call on line 24, and I will dynamically be translating it every time we draw a new branch, so each new branch will grow from a different set of coordinates, even when I hardcoded 0, 0 here in move2 method. So move2 defines starting x and y coordinates, and line2 defines ending x and y coordinates. Line will be drawn between these 2 points. Each line represents a single branch on our tree, so line 2 will take 0 as x and minus length from line 19 as y. I put minus because I want the tree to grow upwards on minus direction on vertical y-axis. So now move2 0, 0 sets starting point in the top left corner of canvas. Here line 2 sets second point as coordinates 0 minus length. So let's say length is 100, so y will be minus 100, somewhere around here. Line will be drawn between these 2 points, representing the first branch in our fractal tree. I call stroke, which will actually draw the line later when we call this function. This draw branches function will call itself over and over recursively every time it runs. It will draw one more line using move2 and line2 canvas methods, representing a branch. It will decrease line width and length to make branches go slowly thinner and shorter. We don't want our computer to freeze, so we can't decrease the size infinitely into very small numbers. Let's say only call itself again to draw another branch as long as length is more than 10 pixels. Inside, I just call draw branches again, the same function we call on line 19. When function calls itself from within itself like this is a programming principle called recursion, and it's a great way to draw fractals. Fractal is a never-ending, infinitely complex pattern that is self-similar across different scales. We are going to draw only a small part of that fractal to make it look like a tree. We can't draw something that's infinite. That's why I'm saying stop drawing the fractal once branches that get shorter and shorter get down to size of 10 pixels. So here I call draw branches again. On line 19, you can see it expects 5 arguments, so I pass it canvas variable again to specify which canvas to draw on. Start coordinates will be array with 0 for x and minus length for y. Here on line 24, where we draw the initial middle tree trunk that will start our entire tree, instead of 0, 0, I pass start argument here from line 19. Since I know that argument will be an array with 2 elements, x and y coordinate, and I know translate on line 24 also expects 2 arguments, I can just pass start here like this and it will work. I only have to put 3 dots in front of it. 3 dots JavaScript used like this are so-called spread operator. It was introduced with ES6 version of JavaScript, and it can be used to spread iterable, which is for example array, we have here, in places where arguments are expected, such as the way they are expected here in translate canvas method. Simply said, if start variable contains 2 elements like this, I'm just spreading them inside translate, like that. It's very simple. Lines 24 and 25 are the same thing. As I said, translate moves what would be 0.00 on canvas, 2 coordinates we pass to it. So let's say we initially pass it this starting position. It will make our entire tree that grows from 0.00 to start growing from here. Okay, let's remove that code. The third argument draw branches expects is length. Every time we draw a new branch, length will decrease slightly. Let's say current length times 0.5. Angle will be always passed to rotate call on line 25, so each time we draw a new branch, I want the canvas to rotate 35 degrees. So the first branch is called here, second one is shorter and rotated like this, and so on. Translates and rotates add up, so every time we call rotate, it will add up to the current rotation, or in other words, rotate even more from the currently rotated position. At the same time, I want branches to get thinner and thinner every time, so let's say current branch width times 0.5. Now I call restore built-in method, which will jump to the last save call. In this case, we called save on line 22, and it will undo all translates and rotates we did between these two lines, putting our canvas back in place, so the tree will be positioned as it should be. You will see in a minute. On line 17 inside main function, that will run when body element is loaded, we create a constant variable I call tree location. This will just be an array with x and y coordinates that define the very first position on canvas where the first branch starts growing from. I want it to grow from the middle horizontally, so canvas width times 0.5, and let's say 95% from the top, so canvas height times 0.95, which will put our tree somewhere around here. To actually place the tree there, I call draw branches for the first time here. I pass it 5 arguments it expects, as we can see on line 21. As canvas, I pass it branch canvas variable from line 16, because that's where I want my tree to be drawn. Start coordinates, I give it my tree location variable, which holds an array with x and y coordinates. These coordinates will then be passed to translate call on line 26, and that will translate position 0, 0 on canvas to these coordinates. So when move2 method runs on line 29 and draws a line from coordinates 0, 0 to coordinates defined in line 2 on line 30, which is 0 and minus length, it will move the starting segment of our fractal tree from here to here. The third argument is length. In this first call, it will be the initial length of the first segment. Let's pass it 100, for example. So the first segment will be from 0, 0 to 0 minus 100. The initial angle will be 0 because I want the first segment to go directly upwards. Then the second and all other calls will set angle to 35 from the previous branch, creating a shape that will look something like this, depending on the angle. You will see in a second. I will also set initial branch width to 20, and we can see here this will determine line width, and here we can see it will get thinner and thinner as we draw more fractal levels. So this is what we have just drawn, one side of fractal tree. You can see these two coordinates on line 17 determine this point here, where our tree starts. Passed here as tree location, and using spread operator, passed the translate call, which moves 0, 0 from top left corner to this position. So move2, instead of drawing from 0, 0, it is actually drawing from coordinates defined on line 17. Line 2 method determines the second point. Line will go from coordinates defined in move2 to coordinates defined in line 2. So for x coordinate, in line 2 we add 0, which we translated here, and for y will be minus length on vertical y-axis. Length is 200, so 0 minus 200, where the first branch will end. And we also pass the same as start value here, meaning the next branch will start from this point. The next branch, that is recursively called, will always start from the point where the previous branch ended. Each time we also rotate canvas by additional 35 degrees from the previous point, so you can see how the branches rotate like this. Then it just recursively calls itself over and over, making the length of branches shorter each time here, until length goes down to 10. At that point, this if statement will be skipped, and restore just removes all translates and rotates, and our tree is complete. I can tweak the initial branch width here, like this, for example. I can also change the initial angle from 0 to something else, making the entire tree sideways. Or I can change the consecutive angles here, making the tree more spread or more compact. Let's put branch width back to 20 and initial branch length back to 100. This fractal doesn't look very impressive, does it? But we have all the code in place now and we understand it, so it's very easy to create really cool shapes. Let me show you how. I'm really curious to see what Radu will do with the tree when I send him the code. If you don't know Radu, check out his channel. I will link some of his stuff in the video description. He can do things I didn't even know were possible with JavaScript. I'm happy he agreed to give us some of his time. Let's see what he can teach us. I was also going to do some kind of snow effect here. That's why I created snow canvas on line 15. But this video is already running too long. Let's just finish the tree and maybe I can use that canvas next time. So how do I make my fractal more interesting? Well, I can for example make each branch to call itself twice. So for each one branch there will be 2 smaller ones. And each smaller branch will sprout into 2 more, and so on and so on. This is called H-tree fractal because at a certain angle it looks like letter H. It can create beautiful complex fractal trees. Important thing here is the angle, which should be set to its minus value for the second row branches, so we get symmetry on both sides. I can tweak these values and look what happens. Now this is starting to get interesting, isn't it? It can also look good if you give each side slightly different values. Not everything has to be symmetrical. This one looks really nice. But this is holiday special, so we want a Christmas tree. How do we make this fractal create a cone shape? One way to do that is to create a third branch and give it 0 degrees here. This will create a middle segment. I will pack this code now and I will send this code to Radu. Let's see what he does with it. If you want to know what he does, check out the next episode in our chain coding challenge. Also, click the like please if you got any value today. See you soon and enjoy your holidays.